Okay, we have been back. Sorry, I was expecting it. The internet died. It's very, yeah, not reliable. So there's nothing I can do about it right now. We are trying to fix it soon, but not like immediately. So we try. We will try. So we were reading this. We were reading the vector. We have the immutable reference. But if we have immutable reference to any of the element, if we change the vector, for example, pushing something, then we will have a set phase because we may have to move the vector to another memory because what if we don't have enough room to store the vector? Then 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 the reference won't be valid. That's why the compiler trying to avoid this kind of problem, and so that's why we can't do that. We can't do this. So you have a set phase doing that. So you just can't. So that's how it is done. So let's look at other things. So this is caused by because the vector could be deallocated. That's why you can't hold a reference and then change anything, even if you're adding new things to it. Assess each element in the vector, and So so this is how we can do the iteration. So it's like we would iterate through all of the element rather than the indexes. We use a for loop. So and we type nv and then print out I. So I in nv. So this is a reference to it because probably we don't want to. Yeah, we need to take a reference to it, I guess. Reference to each element and points them. We can also iterate over mutable reference. For example, then I can change each one of them inside, right? So I can add one of them. I have the dereference because then now you have to use the dereference operator to get the value of I. Before we can use the plus equal operator, because plus equal is basically I equals to I plus 50, so I need to be dereference. Even though like for example this one we don't have to worry about that, but for this one we have to so we will learn more later whether immutably or mutably is safe because the borrowing checker rules. Basically ampersand is a safeguard to safeguard that we won't do anything crazy because the compiler will check all the rules that was there to help us. If we attempt to insert or remove items in the for loop, then the compiler will shout at you because you have the same thing that we do like before, like this one. So we can only change the content in the for loop. We can change the length or adding new things or removing things, so you can't do that. And if you do that, then the compiler will be angry at you. Similar to the one we got. Prevents so because we're referencing to the vector, so it's an immutable reference, and so we can wipe out the vector and then it would be unhappy. Using enum to store multiple types, so we are using enum here. We have in float. Whoa, there's some alarm going on. I hope you won't hear it. I hear it. It's very annoying. In, float, and text. So there are different things. And then we have a vector that store this Yeah, because a vector can only store the same type of value. So if you have different types, then you can make it an enum, right? Because remember, enum can combine different types together, become a new type. So this one will be the spreadsheet cell type, and they can be any of these. So this is extremely useful. Yeah, use an enum, so we can do that. Do it like this. No problem at all. What types will be in the vector at the compile time? How much memory? Because yeah, we need to know how much memory to use on the heap. Storage animals. No explicit about which type are allowed in this vector. That's why we can't have like a vector like a Python list as you can hold anything. It's crazy. You can't because we need to reserve some memory for it. Yep. Cause error. Using an enum plus a match expression means that Rust will ensure at the compile time that every possible case is handled. So you can't have ambiguous type here. So because this enum is written down like it's either any of these, it won't be something that's random. And it's because we have match expressions, so everything will be handled. So if you don't know what type a program will get, then the enum technique won't work because you have to list them all explicitly, right? We can use a trail object, which we haven't learned yet. We'll learn it in the future, so don't worry about that. Assume that you have to know. Yeah, so there are some like documentation about many useful method for vector. Instead of push, a pop method removes and returns the last element. So it's popping the last. Push is pushing something at the end. Popping is removes and return the last element. There are much more. If we are interested, we can have a look. Like this. We have push. We have so there are different things you can do. You can do slicing, indexing. You can look at this new with capacity, all these new things. Yeah, so there are lots of things we can do. And then, like any other struct, a vector is freed when it goes out of scope, so it will get destroyed as well. Do so with V, and it will go out of scope and it's freed. When the vector gets dropped, all of its contents also drop, meaning that integer host will be cleared up. The borrow checker ensures that reference. So you can't hold on to a reference and then it got dropped. You can't. Yeah. Right. Cool. So this is how it works, and then we move on to the next one. Storing UTF-8 encode text with string. So now we talk about string. A string is a bunch of characters. So we will learn more about the string. Yeah. Possible errors is more complicated, right? Yeah, more complicated structure. And UTF-8. What about UTF-8? Right. Collection of bytes. Useful functionality that you could use. Yeah. Discuss the way in which string is different from the other collections. Indexing a string is complicated by difference between how people and computer interpret string data. What is a string? String is a Rust had only one string type in the core language, which is the string slice (str), usually seen in borrowing form and string. In chapter 4, we talk about string slices, which are reference to some UTF-8 encoded string data store elsewhere. String literals, for example, are stored in a program binary and therefore as string slices. Yep, because they are part of something big. The string type, which is provided by Rust standard library rather than coded into the core language. So str is in the core language. String type is in the standard library. That's the difference. Growable, mutable, owned UTF-8 encoded string type. Yeah, so there are two common string types, so we have to be careful. Yep. Now we're talking about string with a capital S. Many of the same operation available for vectors are available with string, because string is actually a wrapper around a vector of bytes with some extra things. Guarantees, restrictions, and capabilities. An example of a function that works in the same way. For example, create a new instance. Remember, we have vec ::new. We have string ::new now. And is mutable is s, and then we can also use toString method to change a literal string into a mutable, like a mutable string. Let's call it mutable string. I don't know. Yeah. So that's the difference. Yeah, it will work as well. Initial content. So you can also use :from, and then you can give it some content as well. Yeah, wow, you can use like many different encoded data. So even if it's in another language, then if it's UTF-8, then it's fine. Yep, just like those. Updating a string. So push, you can push something. So it's like the push in vector. We can also push a string, and then it will be appended at the end, just like the other one. Yeah, you can grow the size. You can actually use the plus operator as well, or the format macro to concatenate. It's a difficult word to say. Yeah, so this is, we are using push string to it, and then s1.push to So mutable s1 is full, and then s2 is bar, and then we push s2 in it, and then s2 is s2. It will be s2 after appending a content to s1. Take a string slice, because we don't necessarily want to take the ownership. Yeah, it will pass by the slice reference. If the push string method took the ownership of s2, then we can't use s2 anymore, because ownership has been transferred. Then we can't use it, like we have discussed a few chapters before. So the push method will take a single character and add it to string. So it's just like, so push will just like push in vector. You will just push something at the end, and it's a character. You can't push a string because it's more complicated, and then you have to use push string. Using the plus operator or the format macro. So you can add them together. S1 has been moved here. You can no longer, yeah, this one I have used S1, and then I can't use it anymore because yeah, so the plus operator will take the ownership of it, and it's poof, it's gone. It's passed into the plus operator, and we can no longer use S1. So if you want to keep it, you have to do something like this with the reference. Take like borrow the reference instead of giving the ownership. So yeah, I guess like push string is using the reference by default, so it's fine, but the plus operator doesn't. So hello world S1 is no longer valid because when use the plus operator, we use the add method. So the add method will take the signature is like this. So the second one is the reference, but the first one is self. So yeah, so it's self. So it's already the ownership is transferred. Call this method a string value. This is very tricky. Like if you are not paying attention, like you will fall into the trap, right? Because if you don't look at the function signature of add, then you don't know that, oh, you're going self and then you're going this. So, oh, now I'm taking the ownership of the self and it's gone. It has been taken. So S2 has an N, meaning that the adding a reference of the second string to the first string. S is the parameter, so yeah, we have to make a reference. N is a nster, so we can't add two string value together. So the type of is n string, not nster, as specified in the So what do we do? So the compiler will automatically change the n mutable string to a n core string. So yeah, use a dref core. What is this? What is this? Okay, so basically it just means that the compiler is very smart. It will do the conversion for you and take the whole string as a slice of the core string. So take the whole mutable string as converted into like a slice of the string, which is like a the whole of it, like the whole cake. I don't know. It's like this, right? And then yeah, chapter 15 give us more knowledge about it. Now we don't know too much, but this is the magic. Because add doesn't take ownership of the S parameter, S2 will still be valid and it will be fine. Yeah, add will take ownership of self because self doesn't have an N, so S1 will be gone, no longer be valid. But actually, yeah, S1 ownership is gone. It looks like it's making a lot of copies, but it isn't. Yeah. So this is kind of be a little bit more efficient than copying everything, but it's also more tricky for my brain. Need to congregate multiple strings. The behavior plus will get crazy and wildly. Yeah, we can't do this, right? Because like. What about this? If you look at this here, what's going on, right? Is going crazy. Well, maybe it will still work, but yeah, I think it will still work, but yeah, it's just my brain is hurting. I guess this will create a new string, and then it will create another one, and the ownership is passed to S. Yeah, is no. S will be a tic-tac-toe plus n characters. Okay. Yeah, it's difficult to see what's going on. So the format will be better, like that. So format is like the print line macro. The format macro works like print. Yeah. Instead of printing it out, it will create a string. Yeah, so format is quite useful. Indexing into a string. So it will. Yeah, normally you think that this is valid, right? Oh, I'm just taking the H here. But no, you'll get an error. Yep, this is wrong. It can't because we are yeah, we can't do that. So doesn't support indexing. So the string doesn't support indexing. Why not? Then again, it's something to do with the memory and stuff like that. So string is a wrapper over the vector. So for example, this one length will be 4. Storing the string hola is 4 bytes long. Each of the letter take 1 byte and encode in UTF-8. In the following line, however, may surprise you. Ooh, it's so it's not Arabic number 3. So this is not a 3. How long the string is, you may say 12, but actually it's 24 because that's the number of bytes to encode this in UTF-8 because Unicode scalar value in that string take 2 bytes to store. So the index into the string will not always correlate to a valid Unicode scalar value. So yeah, if you do this and hello 0, then well, we can't do that. It will have an error. But if we attempt, right, if the compiler lets you do that, then you won't even get this thing that look like a 3, because you are getting the first byte, and it takes 2 bytes to store it. You'll get half of this, whatever this is, like not 3, right? Yeah. So you get half of the not 3. Yeah, it's not a valid character. It'll be crazy. It's probably not what you want to do. So the compiler just don't let you do that. So contain only Latin character, then yeah. Yeah, it will return 104, not H. So to avoid something unexpected and crazy or causing the bug, then yeah, Rust just don't let you do this. It's a very common theme here. If something may cause a problem, then it's not allowed to do it. You can't do this. So bytes and scalar values, and yeah, free reference way to look at strings from Rust perspective. Right, we have Hindi word. I can't read Hindi, sorry about that. But it stores a vector view H value like this. That is a 18 bytes, and is how the computer ultimately store this data. If we look at them as a Unicode scalar, so what the character type is, look like this. There are 6 character value here, but the 4th and the 6th are letters. So these 2 are cray. They are oh, there's something that doesn't make sense on their own. We look at them in the graph. So we need 2 to make up a word. So we need these 2 to make up a word, and these 2 to make up a word. So yeah. So Rust provides different ways of interpreting raw string data that computers store. Yeah, so that's why we can't do indexing, is so because we should not mess up with this thing, because we may not be knowledgeable enough to know how this word is stored in a computer. Um, always take constant time. It's impossible to guarantee the performance with a string. Yeah, because it may be very complicated. How many valid characters are there? So it won't be all one. So it won't be just like go there, take a chunk of it and take it out. No, it won't be like that. So that's what indexing do. Just go there and take it, right? All one, but in a string it's not, because you have to understand the whole thing, understand how things work to get that. So you can't do this. So what can you do? You can do slicing with string. Yeah. So yeah, you can take a range to create a string slice. For example, here 04, so S will be an star, that is like the slice of the string. First 4 bytes of the string. Each of the characters have 2 bytes. So this will be the first 2. If we only try to slice part of the character, what would happen? We would have an error because you can't have half of a character, then yeah, you can't do that. You would have an error. 1 second, let me plug my phone in. Yeah, my phone is running on low battery and I'm monitoring the stream with my phone. So let me plug it in. And okay, hopefully now it's fine. Cool. Okay, I can still see the chat. Good. Right. So we can't have half of a character. So if a character takes 2 bytes, then we can't take just 1 byte. Then we'll have an error. It's not a character boundary. Then so yeah, you can't even have like 3 then, because there's like giving the first character and then half of the second one. No, you can't. So yeah, those were clusters. So getting a slice out of a string that is encoded more than 1 byte. So like, for example, if it's not UTF-8, then it will be a little bit tricky, because then yeah, then you have all this problem. We have to deal with all this pain. In Python, we don't care. Oh my god. Okay, method for iterating over strings. Best way to operate a slice of string is to be explicit about whether you want character or bytes. So yeah, so instead of doing crazy things like indexing or slicing, indexing is not allowed, slicing is crazy, we can use the dot character method. So calling chars on that will separate out the returning 2 values of the characters. Yeah, so it will give you the characters instead of giving you the bytes, which is a little bit difficult to deal with. So the bytes method will give you the bytes, so it will give you 4 numbers. Yeah, so it makes up more than 1 byte. So these 2 will combine to make the first character, these 2 will combine to make the second character. Yeah. Yeah, it's very complex if we want to get the script of the Hindi writing. So it's not provided by the standard library. You have to find a special library to do it. It's so specific. Yeah. So you have to find on Crane.io to see if there's other libraries that would handle this special writing script. Yeah. So I'm sure there will be, but yeah, it's just how it works. Oof. Strings are not so simple. That's true. I agree. You are right. Book. You are right. So yeah, tricky bit is that a string is actually a bunch of bytes, but how we interpret it depends on the language. So yeah, if we want to handle them as character, we better use the character method. If you want to handle the bytes yourself, is difficult. So yeah. Standard library offer a lot of functionality to help you out of this rabbit hole. Yeah. So ASCII character is simple, right? It's just that, like, you know, every byte is every character. But if it's something that, like, they use more than one byte for one character, then a crazy thing may happen, and you have to be careful. Yep. We all know that. We all know, like, if we have been using the internet long enough, then we all know anything on ASCII is a bit tricky. Yeah. You can use method like contains to search for something in the string, or replace to replace something in the string. Yeah, I think in the future when we use them, we can look it up. So next, moving on, installing keys with associated values in the hash map. So last thing is a hash map is basically a key value pair, mapping of key type and a value in a hash map. Support this kind of data structure like a dictionary in Python, I guess. Yeah. Is a hash, is a map, is an object, is a hash table or dictionary, yep, or associative array. But we are called hash map here in Rust. Okay. So, creating a new hash map. For example, right, useful when you look up something not by the index. Okay. So we create a new one. Just use new, like a lot of different things. We just call new. Always in collection as well. We have to call it either from this, or you can just do this, and then we can just hash map. So scores. We put two things in. We put blue 10 and then yellow 50. Okay, so the key is the string, and then the value is a number. Right. There's key of type string yet and value of I32. Homogeneous. All the key must have the same type. So you can't have like a string and then something. Yeah, that's true. Of the value must have the same type as well. So you can't have the. If you are storing different types, I get that would be a struct. It's not a hash map. Yeah. So you can, if you provide a key, you can get the thing using the key method. So team name, for example, team name is blue, and you get the reference of it. So it's blue, the literal like text here. Then we use the get method, get the score, and then we copy it. So what's going on here? Let's see. If I have the value that is associated with team blue, the result is 10. Get method will return a option. It's an option. Yeah, because what if the key is not there, right? So again, like get method will always give you a potential none there. Yeah. Handle option by calling copied. So you can. So that's why we need to call the copied to get the get an option I32 instead of the reference. Then use unwrap or to get the score to 0. If it doesn't exist, then it's 0. Yeah. So have any entity for the key. Okay. So this is all these like methods doing for you. Instead of you have to write the match and you're at the arms yourself, then it will, all these can handle the option for you. Iterate over each key value pair in a hash map in a similar manner, using a for loop. So we can have a pair, key and value, hash map and ownership. So ownership things. implement the copy trait like I32. Values are copied into the hash map. So for example, the string, the value will be moved and the hash map will be the owner of those. Yeah, so for simple thing like the integer and everything that have the copy, then it would just be the value that got copied, but for something like string, then ownership will be transferred. So insert field name and field value. From favorite color to this one, invalid field name, and so because you have used insert, so both of them will be invalid. Yep, and then you have an error if you try using them after. If the insert reference to the value won't be moved into the hash map. The value that the reference point to must be valid at least as long as the hash map is valid. So now, like, you can't die before the hash map died. That's what it is. Okay, and updating the hash map. So I can now update the hash map. Although the number of keys and value pairs are growable, each unique key can only have one value associated with it at a time. Not vice versa. So the keys need to be unique. So you can't have 2 team blue or 2 team yellow. But team blue and yellow can both score 10 in the hash map. So yeah. So how to change the data, right? Replace the old value with the new value, completely disregard the old value, keep the old value and ignore the new value, only adding the new value if the key doesn't already have a value. Combine the old value and the new value. So there's a lot of way of updating a map. So overwriting a value, how to overwrite the value at all, like, so if we insert a key and a value into hash map that have the same key as with a different value, the value associated with that key will be replaced. So we will keep the new value. So if we insert blue 10 and then blue 25, then we will have 25 at the end. Because we are inserting the value for the blue team's key both times. Yeah. Add a key and a value only if a key isn't present. So we need to check if it's present first because we don't want to overwrite it. If the key does exist in the hash map, the existing value should remain the way it is. If the key does exist, then you can insert it. So it's called entry. Entry, take the key you want to check as a parameter. Return the value of the entry method is an enum called entry that represents a value that might or might not exist. I want to check whether the key for the yellow team has a value associated. If it doesn't, then we insert the value. Okay. So we already have the blue team is 10 and then entry yellow or insert 50. Entry blue. So what happened here is that all insert method on entry is defined to return a mutable reference to the value, the corresponding entry key. If yellow exists, right, then it will give the reference to the value. So now I can insert 50 in yellow. But if not, the insert parameter return a mutable. Insert the parameter as the new value for this key and return a mutable reference to new value. Right. Place more lines with the borrow checker. So if the key exists, it will give you a reference. If not, the insert parameters the new value. So running this code will give you a 10 and 50. So if it does not exist, then you can insert 50. If it does exist, then it won't do anything. Then this one will be the reference. Like, if it already has it, then it will have a reference to this 10, I guess. The first code entry will insert a key for the yellow team with value 50 because the yellow team doesn't have a value already. The second call to entry will not change the hash map because the blue team already has the value 10. I am intrigued. So let's see if I do this. I want to test it out. So let's do this. And then cargo, new hash map. I want to have a look. Well, like, I want to do it myself to understand what's going on. So if we do this, and if we run, we'll get the same thing, right? So cargo run. Oop. Let views go. What's going on here? I just copy this and then it doesn't work. Use let view. Score equals to score. Interesting. Why you give me an error? Accurate let unexpected item. Ooh. Why? Did I miss something? Collection. What's going on here? Why I'm not allowed to do this? Score equals to like that. Is it not like the hash map or something? Oh. Shrink. If mute. You should just give me a warning, right? Oh. What's going on here? Oh, someone's coming to help. The oracle is visible per default in the example. Press the I button to the okay. Let me have a look. Yeah, the main thing. Exactly. Thank you. So now I know what's going on. Yeah, this is I see. That's why I go crazy, because I forgot the main. Okay, now it should work. And then if I have if I want to see this, right, like, yeah, how entry work. So if I put that, so what should I do? Like, blue goes to, so will I be given something here? It should be a reference though. So do I do this? Do I do this? What will happen if I do this? Yeah. Or what will happen if I put it here? I don't know. Let's see. Yeah, I would get a 10 here. So I would get it back if it's already exists. If it's not, then it will insert it, I guess. Yeah. So this is quite tricky entry. So if you give you this entry thing that have a value may or may not exist. Yeah, it's very interesting here. So what if this get back here. Oops, I will have something. First mutated borrow, so this will be this entry will give us something back, right? Yeah, what is this? Interesting. Mutable reference to a value corresponding. So all insert method and entry is defined to return a mutable reference to the value if the key exists. If not, insert return a mutable reference to the new value. Is a mutable reference to the new value, so I can't do this. Yeah, so now I get back 50, but then because it's a mutable reference, I can't have blue as well, also as a mutable reference, I guess. Yeah, so both of them are mutable reference, so I can't have both. Yeah, we can't have two mutable reference. I can't do that. So that's why it was panicking before. Okay. Right. Standard library documentation of dot entry. Standard library documentation of entry. Do I have the standard library? I have to go to this, right? Wow, I'm blind. Rust as a documentation. Standard library. Okay, so if I look at entry. Hash map entry. So let's get with entry here. We'll give you back entry with the thing. So this entry object, right? You can also like modify it and do a lot of things with it. Let me have a look at that. Enum entry object is occupied or vacant. So both will give you a mutable reference according to the other page. Occupy entry or no, it's like the or insert will give you a reference. So it will have two things. It will have occupied or vacant. So I guess or insert will do things with it, right? We'll give you the mutable reference of the value here. So yeah. There's a bunch of things you can do with it. This is a rabbit hole. Let's store it for now. Let's just go baby step. Let's just go with the basic. The basic thing will help me. So, yeah. So okay, we have demystified this a little bit at least for the very basic things. So updating a value based on an O value. So common use case for hash map is to look up a key value. Update it based on O value. How many times each word appear in some text? We use a hash map to count them. And so, for example, we have "Hello World, Wonderful World," and then we have a map that we created. Okay. And then we would have this text, and then split with white space. I guess it will give you each word, and then word in that, and then map the entry word or insert 0. So this is very useful. This is like we have done that a lot in Python as well, but every time we have to first check if there's like if it's in there, if the key is there. If it's not, then we have to add a new thing. But like you can use entry. So if this doesn't exist, it will be 0. If it does, then we would have the reference back, which is the count, and we can dereference it and add 1 to it. So this is what's going on. This is very handy, very concise and small. So now you get the result like this one. Yep. Cool stuff. Yeah, there's lots of syntactic sugar in here. It's so nice. Right. It's a hash. Okay, hash functions. Zip hash. Resistant to denial of service. DDoS attack. Ooh, okay. Why suddenly talk about DDoS attack? Involving hash tables. This is not the fastest hash algorithm available, but the trade-off for better security come with a drop in performance is worth it. Profile your code and found the default hash function is too slow. Switch the alloc function by specifying different hasher. Okay, so you can build your custom hasher as well. You can also switch it to a more secure hasher. Yeah, so I think again this is another rabbit hole. I think I would. You can inline the counts really. Okay, I guess you can. Yeah, but no. I'm a baby, so let's do something very simple first and not dive into the rabbit hole. I think, yeah, this is good to know, but I'm not going to dive in. Otherwise, I would be sitting here for another 10 hours, which is not good. I have things to do after. So, vector string and hash map will provide a large amount of. Yes, I agree. It's very handy. Give a list of integer vectors would return a. So we have games. Do we have time for games? Let me double check. I think we have time for games. Let's see. I think we have time for games. So let's do game. Give a list of integer. Use a vector and return the median when sorted. The value in the middle position and the mode. A hash map will be helpful here as well. Median and the mode. So use a vector and return a median and a mode. So do we have the sort here? Or do we have to go through them? Yeah, this is a bit difficult. So, but we can try. So this is mode and so I don't know. I know how to find mode, right? Mode is just like counting the words. But median, we have to sort it. So, yeah. All right. So it's not mean. Mean is easy as well, but like median, we have to sort it out first. Yeah, result of a hash. Yeah, so a hash is not very secure if the hash algorithm is not safe, right? Very predictable. I could use input values that all result in the same hash. Yep, guess they can guess the hash very easily. Okay, so what do we want to do? So let's do toggle new list of int. So let's see, list of integer. We have that. We have a list of integer. So let's let list of int equals to just something for now. I don't know. Something, right? And then we can make it better, like more sophisticated later. So we want to put them in a vector. So let vect of int. Can I use the vec exclamation mark and then list? Or I should use the, like, I should make it like that, right? Or put it into, you know what, let's make it simple first. I like making it simple, and then we would blow our mind later. I'm a bit tired as well. It's been a long day for me. So finding the mole is just like using a hash map. So do we have a sort method for vec? That's a good question. Let's find out. Let's search. Let's try vector vec. Vec new this. What do we have? What do we have? What do we have? From raw parts. Something like sort is sorted by oh, this is not from vec, no, or what is it? This is not what it is. Wait, let's step back. So vec here, I have a sort as well. No, something like that. We have slice. We can sort the slice. Vect. Do we have to, I don't want to write our own sort. This is silly. Iterator. Slot the slice. Only a slice can be sort. Oh wait, what is this? So it's stable b dot sort. This is a slide, and you can slot a slide. Can I sort it and put it in the back? Can I do that? Maybe I can do that. B dot sort. No. Okay, let's try this. All right, we have this, and then we have so we need to be mutable. And then can I do this? Can I check the macro whether it could do the, or we Yeah, let's go back and check the vec thing. Oh, nope, we're wrong. Okay. Oh, and that can be the reference to slice. Interesting. Ah, you can use from. I see, I see. Okay, let me see if I can find the documentation to from. Then I would be. It will be really helpful. So in the thing slicing, can I look at the from? So how is this sorted? It's not really sorted, isn't it? From raw part, no. It's not the easiest to search. Oh, I'm just dumb. The slice is pointed to the start of the array. And in length. Can I find it? Do it here. Type of search here. I don't quite know how to use the website, but if there's a from, then maybe I can do that. Yep. From. So vector examples. DQ. Give you a vector is, but yeah, let's put the DQ in there. From iterator. Or from another vector. Binary heap from from a string, from a C string, from a binary heap, from maybe we should just give it a try. I am very confused, but well, so this will be std vec, right? Or am I wrong? Or I can just use vec because it's there. Right, where are the examples? Let's go back to the examples. Yeah, you can create a vector like that. So maybe VEC like that. Let's try. Vec also have a sort. Oh, okay. Let's try that first, and then see how horrible it is, and then we'll know. And then list of vec of in. Oh, I'm so tired. I'm so sorry. I'm at the urge of like falling asleep. Okay, so what have I done? Okay, cargo run. So this cannot be formatted with the formatter. Can I do the question mark thing? If this will work. Yep. So it'll give me something that is sorted. It's kind of ugly. I guess you can just create a vec and then sort it. Let's put it like this for now. Yeah, because I'm lazy. And okay, so then I can just get the median, which is I need to get the length of it. So do I have a length? Let's try all of the things. So so if I have that, I can print it out. I can also print in. Oh, will I get a length? Like that? Will I get anything? Nope. Unexpected. Oh yeah, cool. Oh, I got the length. So I guess I just get this value out and then equals to this, and then if percent to, or maybe I can do the match. No, percent to, and then if it's 0, then I will print I need to find the, so if it's divided by 2, then I need to divide the length by so I have to divide it, so the index of it is so I need to get the I would do multiple things, not to confuse myself. So median equals to, so let median equals to the length divided by 2. So if it's like for example 6 divided by 2 is 3, and then I need to add index 2 and 3, right? So so to be list vector of int, I want to reference, right? 2 plus this one minus 1. Oh, it's so ugly. I will format it. I will format it. It's so ugly right now. Okay, so this one divided by 2, and then print median. So if not, if it is a comma, right? This one also, or the semicolons. So if it's 1, then I guess I would print out the median, or I can print out the median nevertheless. Can I do this? No, actually I can return this as something, right? Language server support, what is that? I'm not so sure. Can do something like that, right? Can do something crazy like that. I don't know. Maybe I'm crazy. I don't know. Let's see. So if it's that, then if for example it's 5, if it's divided by 2, it will be 5. It'll be truncated, right? So it will be 4 divided by 2 will be 2. So I get the 0, 1, 2. So I will just get the thing. Yeah, so I will just return that, I think. Then print median. I'll leave it like this for now. Oh, no, something's wrong. Opening, oop. Length, oop. Missed that. Then this one, match median. It will return something, right? And then it will return to this. I think like that. No. Whoa. Integer. Okay, let's debug. I need to let like that one, right? Oh, it's not in this scope. Yes, that's correct. So turn that. Or I can make it easier by just printing it out for now. Maybe I can just print it out for now. Okay, let's make it simpler. Like that. Just print it out. Not worry about the syntax and everything for now. Let's just match. Yeah. Oh, to do. Am I missing something? Am I missing something? I can use inline now, no? Like that. And then this one. Oh, maybe I don't need that. I don't know. Okay, it's very ugly, but I am missing a comma at the end. Okay, so I should not use a semicolon. I should use a comma, right? Let's try. Because it's an arm, maybe because it's an arm. Oh, it's still missing some. It's. What if it's something else? But it's 2. It won't have something else. But I can try. Like this, right? Nothing. Let's give me 3, which is wrong. Okay, what's going on here? It should not give me 3. What's going on? So this one and this one, so length divided by 2, so length is 6. Length is 6. Length is 6, and then 6 plus 2 is this is 0, right? Yep, 0. So 0, then it will print out the. So this is length divided by 2, so it's 3. So 0, 1, 2, 3. This one, right? I'm just checking everything now. So it's 4. So this one. Wait. Length divided. So. Am I crazy right now? 0, 1, 2, 3. What? What's going on? Place the LED in front of the match. Yeah, maybe I will sort it out later. But what? This is 4. This gives me a 4. Okay, one sec. Oh, the token. I know I'm gonna make this mistake a million times, then I will learn. And I'm forgetting the exclamation mark as well. 0. It's sorted. Yes, okay. You are right. So I'm getting 3, but it should be. Oh, I know. This should be floating point number. It needs to be float. If it's a median, then it needs to be float. How can I make this float? I can make this 0. I don't think it will work. We'll see. Yeah. You can't do that. So how can I change it into a float? So this is getting unnecessarily complicated. How can I change it into float? How can I change it into float? How can I change it into a float? Yeah, round down the default. Yeah, it. We can ignore it for now. We need to change it into the float if we want it to be floating point number. Yeah, but then we have to do something about it. No. Or maybe we can Google. You can use .into as a IF64 casting. Okay, give this a try. That's better than ChatGPT. My chat is better than ChatGPT, I'm telling you. .into F. I think 32 is enough for now. Let's do it like that. Let's see if it works. Oops. It doesn't work. Try explain. Blah 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 blah. Errors. Not a value. Do I need to put it a string or something? No. Okay. Good old Google. Rust. Convert. I can't see any code. Do I use a est without the type? Huh. So it's like this. Right, let's give it a try. Something, 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 something. You know what? Due to the time constraint, we just ignore it for now. Just imagine this mathematic is correct. I'm going to die. So, okay. So the mode is gonna be doing what we do with the counting word game, and then print out the biggest. So we are going to use what was the thing? Hash map will be useful here. The most occurred offer. So I could create a map. So if I create, so this is median. Is right. Okay, doesn't matter. Just that, and then if I want to do a hash map, which we did that before in the here, right? Yep. So we create a map like that, and then we use a for loop. And then we use a for number in list vector of int dot. Can I just do this? Let's just try. No, like that. Yeah. Okay. So print. Just print out the number. For now, let's see what's going on. See if it works. No, hash map. Oh, I forgot to use. I know where you are. Come here. You're super ugly, but doesn't matter. Just do this one now. It doesn't like it. Mute map, hash map. New type annotation needed. Ooh, I think because I haven't put anything in it, so let's just not do this for now. Yeah, so it print out 1 2 3 4 5 6 7 8. That's fine. So now I can push it in the map. So I would use the entry method, right? So this is a similar thing. So use the entry method. So entry number. All right. So I'll count them. So now I have to find the one with the most count. So if I print, all right, this one doesn't repeat, so it doesn't make any sense. So let's change it into 8, right? So I'm missing everything, like that, and then I'm doing this. Print this out with the hash map. Let's see. Okay, so 2, I got 1. Yeah, how can I go take out the one with the most value, the biggest value? Is there any function? Is that the library? Hash map. Okay, tell me what you have. With hasher, you can change the hasher with keys, values. To mute. Yeah, I may have to finish this soon and then pause and then come back to this game, because there's like 3 exercise and I'm still struggling with the first one. So I may come back to do it later. Entry, get key value. Ooh. So this is getting both the key and the value. Do I have to manually find the biggest one, or do I have to write something to find it? Yeah. Use the iterator of B-tree map drop in placement. What is a B-tree map? Is this going to be a rabbit hole, isn't it? Okay, I'll have a quick look, and then I will have to pause because I have things that I have to do. So I would probably take a break and come back and then do the do my thing that I have to do, and then come back to do this. B-tree map. Global. Oh, it will create a struct. Okay, I think I'm gonna save game. I'm gonna save game. Like, my brain and my body is basically telling me to stop. I have something else in half an hour. I need to take a break before that, and then yeah, we'll come back to this game. Is this fun? Is a sorted map. Oh, that would be handy, but I have to look at how to use it. And also clean up this mess. I'm now too tired to clean up this mess. I would save game here. Now I'm not going to touch it. I'm not going to cheat, and I will come back hopefully later today, or if I can't, then tomorrow, to fix this. But this is fun. I like it. I'm just too tired at the moment. Yeah, so thank you for your tips. Refo is your username. Thank you so much, and yeah, give me a lot of tips and stuff. I was like really struggling. Thank you so much. And yeah, so whoever can drop in next time, maybe they can also help me out. So thank you so much, and yeah, so see you next time.